Hi guys, so thank you for coming back for another exciting problem. Okay, yeah, they're not exciting, but whatever, we have to go to school. Okay, so today we are gonna wrap up our division unit with polynomials, but we're gonna talk about a really cool way to divide polynomials, something called synthetic division. So sometimes I say, oh, synthetic division is a shortcut, but it's not really a shortcut. It's more like a shorthand for long division. And the question is, oh, Miss Torres, how come we didn't do this before? The reason why we didn't jump to this technique is because we can only use synthetic division for certain division problems. Okay, synthetic division, we can only use it if I'm going to use my fancy math words. Synthetic division, we can only use it if we're dividing by a linear factor of the form x minus a. So like in English, so if we're dividing by something that looks like x minus a number. Okay, so like example, x minus 1, x minus 2. What if it was 2x minus 1? Oh no, that's not x minus a number. Okay, so yeah, so synthetic division is a shorthand when we're dividing by a linear factor of the form x minus a. So it's a binomial of the form x minus a number. Okay, so where did I put? Okay, I'm gonna speak to you. Okay, so how do we divide polynomials by using synthetic division? I think the way I'm gonna do it, instead of reading this to you, I'm gonna start writing the problem. Okay, let me get a separate sheet of paper, so I'm going off my script. Okay, so it says fun problem, divide. If you want to use synthetic division, then go for it. Okay, so let me go ahead, write out the problem. Okay, so this is what happens when you go off script. Remind me not to do this again. Okay, so I'm gonna put a fun problem, because we don't call these examples. Examples are boring. Okay, we call them fun problems. Divide, and that's it. I'm not gonna put the rest. Okay, but if it just says divide, I guess we can use the technique of our liking. Okay, but because I want to promote synthetic division, that's why I put, if you want to use synthetic division, then go for it. Now these problems are not typed, so let's go ahead and write them together. Okay, so we're gonna do 3 problems. So fun problem A, we have, okay, open parenthesis, 6x cubed minus 4x plus 5, close parenthesis, and we want to divide that by open parenthesis x minus 2, close parenthesis. Okay, the question is, so we have to divide. Yes, we can use long division, but we want to know if we can use synthetic division. We want to know, can we use this shorthand? The first question is, can I use synthetic division? I don't know. Am I dividing by a binomial of the form x minus a number? Okay, so let me speak to myself. X minus a question mark. Okay, I love writing my thought process on paper, so that's why I write it how I speak it. Am I dividing by a binomial of the form x minus a number, or x minus a? Okay, the answer is yes. Okay, so that makes me happy. Okay, so let me identify the value of a. So the value of a is the number that follows the subtraction sign. So in this case, the value of a is 2. So let me go ahead and write it out. Right, a equals 2. How are we going to prep this up? So how do we do it? So it says step 1. You know what? Why am I reading this to you? I'll just leave it right there, and then I'll speak to you. Because if I read it to you, it's going to like throw me off. Okay, so 1, identify a, and then 2, prep up for long division. Okay, prep up for synthetic division. So what we're gonna do like this upside down into symbol. The reason why we call it upside down into symbol, well, what I call it, because the into symbol is like this, but then we want to do the division box, which is the upside down into symbol. Okay, sorry, let me zoom out. Go. How are we gonna set this up? Outside the division box, or what I call the upside down into symbol, we're gonna put the value of a. Let me go ahead and speak to myself. Value of a, which is 2. In this division box, we're gonna have 2 rows of numbers, top row, bottom row, and then in the bottom we'll have some cool stuff. In the top row, we're going to put the coefficients only of all the terms, okay, in descending order, okay. Something that I recommend to my students is for you to highlight the degrees. This makes it a lot easier to see if we have a missing term or if it's in descending order. So let's look at the degree. The degree is 3, so we need to have an x to the third, x to the second, x to the first constant, okay. So let me highlight the degrees. So I need space for the numbers here, so put it above, okay. The degree is 3, so it would be nice if we had an x to the third, x to the second, x to the first constant. I say constant, but it's because the degree of a number is 0, okay. So it's 3, 2, 1, blast off. Let's go ahead, put those coefficients. The coefficient of the degree 3 term is 6. The coefficient of the degree 2 term is nothing, okay. We don't have an x squared, so if we were gonna do a long division, we would be like, oh, dog breath, we need a 0 placeholder, okay. So we're gonna put a 0 placeholder here too. So we have x to the third, x to the second, x to the first. The coefficient of the degree 1 term, or the x term, is -4, and the constant term, or the degree 0 term, is 5, okay. So our first step before we begin the division process is to prep this out for synthetic division. So 1, identify A. 2, go ahead, do the division box, which is the upside down into symbol. Outside the division box, we're gonna put the value of A. In the top row, we're gonna put the coefficients of all the terms in our polynomial, making sure they're written in descending order, of course from highest to lowest, and then we put 0 placeholders if needed. Cool. So now that we prep this up, now let's go ahead, let the division begin. Okay, so step 1, I know it says step 2. Okay, step 1, it says bring down the first number. Cool. Bring down the first number straight down, and then okay, you know what, I said I wasn't gonna read to you, sorry. Okay, yeah, I'm gonna put this away, this is getting in my way. Okay, I know how to do this, so I'll just talk to you. Okay, so how are we gonna proceed? How do we divide by using synthetic division? Okay, step 1, bring down the first number. That's it, no other math. Bring it down. Now we're gonna do some math. Then we're gonna take this number and multiply it by A. Okay, 6 times 2 is 12. Because I want to remind myself where the 12 came from, with your permission, I'm going to go ahead, put the time symbol, and then I'm going to circle it. Okay, so how do we divide by using synthetic division? 1, bring down the first number. 2, multiply by A, so 6 times 2 is 12. 3, we're going to add the results. Sum of 0 and 12 is 12. And what do we do next? Same thing, multiply. Okay, let's keep our cool. Product of 12 and 2 is 24. And what do we do thereafter? Repeat. Oh, I love stuff that keeps repeating. Okay, sum of -4 and 24 is 20. And what do we do thereafter? Again, repeat, multiply. 20 times 2 will give us 40. And then we add the results. Okay, sum of 5 and 40 will give us 45. Okay, something that I failed to do because I was a little bit excited. After we write down the coefficients of the terms, let's go ahead and make a separator. Okay, I like to do a dashed line because when I make it solid, it's a little too busy. Okay, now we're pretty much done with the math. Now we have to spit out the answer. Where is the answer? The answer is given by the numbers in the last row. Okay, so the degree of our quotient will be 1 less than the degree in the dividend. Since we divided into a degree 3 polynomial, the degree of our answer will be 1 less. So we divided into a degree 3 polynomial, 1 less will give us 2. Okay, so 6 will be the coefficient of the degree 2 term. And then we keep going down. So we have x to the second, x to the first, constant. What about 45? Is it going to be x to the negative 1? No, this is actually the remainder. Now, why is it that the degree of our quotient, well, let me just go ahead and put quotient. Why is it that the degree of the quotient is 1 under? It's not because the book said so. It just comes from math, okay? Like if we were going to prep this up for long division, where am I? 6x to the third plus 0x squared minus 4x plus 5. Okay, it just comes from math. You know, we're not going to finish it, but when we divide, I want to know how many times does the first term go into the first term that we see, and x goes into 6x cubed, exactly 6x squared times 6x squared. Okay, cool. So yeah, it's always the degree of the quotient is 1 under than the degree of the dividend. So that's our answer. Let's just snake it through. So we have 6x squared. 12 is positive, so we're going to put plus 12. 12x. 20 is also positive, so we're going to put plus 20. And we don't put x to the 0. And if you put it by mistake, then just remember that x to the 0 simplifies to 1. And then this loose number right here, that will be the remainder. So we're going to write it as plus fraction. Okay, the remainder is 45, and we divide it by x minus 2. So as a fraction, we're going to write the remainder as 45 over x minus 2. To check it, you would check it the same way that we did it earlier. You know, quotient times divisor plus remainder should give you the dividend. I'm not going to check it. I'll hold you accountable to it. Okay, so I think this will be the longest one because of all the explanation and the little stuttering. Let's go ahead and do 2 more and we're out. Okay, problem B. We have open parentheses 7x minus 15x squared plus 3x to the fourth, close parenthesis, divided by x minus 3. Fantastic. Okay, so we are asked to divide. Yes, you can do a long division if you want, but I'm going to ask myself, can I take a shortcut? It's not a shortcut, but that's how I speak. Can I take a shortcut? Can I use synthetic division? Am I dividing by a binomial of the form x minus a number? To be more specific, x minus a. And the answer is yes. So let's go ahead and do this. So let me highlight the value of a. So a is a number that follows a subtraction sign. So in this case, it's 3. So if I ask myself a question, I'm going to answer myself. That's just how I speak. Okay, so let's prep this up for synthetic division. So we're going to go ahead and do the division box. Outside the division box, we're going to put the value of a. Value of a, where am I, is 3. Inside the division box, we're going to have 2 rows. Top row will be the coefficients of the terms in the dividend. Bottom row will just be our work. And then final row will be the answer. Okay, so let me highlight the degrees. The degree is 4, so I need to have an x to the fourth, x to the third, x to the second, x to the first constant. I know I should be a hand model. Okay. So we have x to the fourth, x to the third, x to the second, x to the first constant. And before I forget, let's go ahead and separate the quotient from the remainder. Okay, so that way, like, the terms before our separator will be the terms in the quotient, and the term after the separator will be our remainder. So let's do this. Let's plug in the numbers. So where am I? X to the fourth, the coefficient is 3. Coefficient of the x to the third, we don't have an x to the third, so 0 placeholder. Coefficient of x to the second is negative 15. That's a 5. Coefficient of the x to the first is 7. Coefficient of the constant term or constant term, unless my eyes fail me, we don't have a constant term, so we're going to put another 0 placeholder. Do we need a 0 placeholder for the constant term? Yeah, because if we're going into space, what do they say? 4, 3, 2, 1. If there's no blast off, you're gonna stay on Earth, not in the moon. So yeah, we need a term with a constant term as well, or the degree 0. Okay, so we prepped this up for synthetic division. So now let's begin to do the math. Okay, so the procedure, we're going to drop down the first number as is. And then we're going to multiply and add like there's no tomorrow. Product of 3 and itself will give us 9. And then we're going to add the results. Sum of 0 and 9 is 9. And then we're going to keep going. So multiply, add until you can't no more. Product of 9 and 3 is 27. And then that difference, oh, I could be wrong, is 2 with the 1. Or 12, like normal people speak. Okay, let's go ahead, multiply and add. Oh, I forgot my add sign. So let's do this. Product of 12 and 3 is 36. And then the sum, if my eyes don't fail me, I think it's 43. I need to stop saying that. For the grand finale, product of 43 and 3, there's a 9 with the 12 in front, or 129, how normal people speak, okay? And then we're going to add our results. And the sum is 129, okay? So unless I made an arithmetic mistake, I believe that's the answer, okay? So let's go ahead and do this. Let's go ahead and write down the answer. We divide it into a degree 4 polynomial, so the degree of our quotient needs to be 1 under, or 3. So we have x to the third, x to the second, x to the first, constant, and remainder. So let's go ahead, earn our full credit, and snake it through. Okay, so we have 3x cubed plus 9x squared plus 12x plus 43. And again, if you bring down the x to the 0 because you're nervous, then just simplify it. X to the 0 is 1. Okay, plus this remainder, so plus 129 over the divisor of x minus 3. Okay, so I said we were gonna do 3 problems. Let me go ahead, bring down the third and final problem. Okay, problem C, we have open parenthesis 1 plus x to the 5th, close parenthesis, divided by open parenthesis x plus 1, close parenthesis. Okay, so the directions are to divide. It doesn't say what technique to use, but you know, I pretty much told you, like, you're encouraged to use synthetic division. What if you can't use synthetic division? Then I guess we use long division. So the first question that I ask myself is this: can I take a shortcut? Can I use synthetic division? I don't know. Am I dividing by a binomial of the form x minus a number? Okay. At a first glance, I'm crying if you can see my face. At a first glance, it looks like I cannot divide by using synthetic division because we don't have x minus a number. But what if we forced it? Okay. What if we rewrote the addition problem like a subtraction problem? Why don't we write it as x minus -1? We can always rewrite things as long as we don't change the meaning. And last time I checked, subtracting -1 is the same as adding 1. So thanks to our detective skills, oh, now I'm crying tears of happiness. Thanks to our detective skills, to answer the question, can I take a shortcut? Can I use synthetic division? Am I really dividing by a binomial of the form x minus a number? We've fixed it, so the answer is yes. So now in this case, the value of a is -1. Why? Because a is the number that follows the subtraction sign, x minus a, x minus a number. So let's prep this up so we can leave. So we're going to do the division box. Outside the division box, we're going to put the value of a. Value of a is -1. Top row, we're going to put the coefficients of all the terms in the polynomial that we're dividing into. Bottom row is our work. Final row is the answer. Okay, so let me highlight the degrees. Oops. The degree is 5. So we need to have an x to the 5th, x to the 4th, x to the 3rd, x to the second, x to the first, constant. This is in my way, so let me just go like that. Okay, and then while we're at it, let's go ahead separate the quotient from the remainder. Okay, let's go ahead write it in. Coefficient of the degree 5 term is 1. We don't have an x to the 4th, so 0 placeholder. We don't have a x to the 3rd term, another 0 placeholder. Oh my goodness, it's never ending story. We don't have a term for the x squared. We don't have a term for the degree 2 term, so 0 placeholder. X to the first, we don't have an x term, so 0 placeholder. What do we have? Do we have a constant term? Yeah, okay, finally. Alright, so we prepped this up. We are on our way to get full credit. So let's do this. So we look at our notes. The first step is to bring down the number as is, the first number as is. That will give us 1. And then we're gonna multiply add until we can't no more. Until we can't anymore. I need to practice my English. Alright, let's do this. Product of 1 and negative 1 will give us negative 1. Then we're going to take our time and add the results. Oh, I hope this one's on the test. Sum of 0 and negative 1 will give us negative 1. And again, we multiply add until we can't anymore. Check out my English skills. Alright, negative 1 times negative 1 will give us 1. We take our time and that sum will give us 1. Multiply add again. Product of 1 and negative 1 will give us negative 1. When we keep our cool, that sum will give you negative 1. Fantastic. Almost done, guys, with the problem and the day. Product of negative 1 and negative 1 will give you 1. I feel like a broken record, but I'm not purposely saying those things. Those are the numbers, okay? So multiply, add until you can't anymore. And then that sum will give you 1. For the grand finale, I think, product of 1 and negative 1 is, where am I? Negative 1. And then that sum will give us 0. Fantastic. So we're done. Let's just earn our full credit, okay? We divided into a degree 5 polynomial. So the degree of our quotient or answer needs to be 1 under, which is 4. So we should have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, constant, and remainder. Okay, so let's go ahead snake our answer. So we have 1 x to the 4th, but we're just going to write x to the 4th. What if we put a 1, then erase it or just omit it in the next line? We have then followed by minus 1x cubed, but wouldn't look nicer if we just put minus x cubed. Minus x cubed plus 1x squared, or preferred x squared, minus 1x, but you know me, preferred minus x. 1 is positive, plus 1, and then we ignore the x to the 0, or if you bring it down because you're cool like that, then simplify it. X to the 0 simplifies to 1. What about the remainder? Check it out. The remainder is 0. So if we don't have a remainder, then we don't highlight it. Like if I say, hey, how much money do you have? And let's just say you have a $5 bill. You're like, oh, I have $5. You don't say like, oh, I have $5 and no cents. When we don't have something, we don't highlight it. So same thing with the remainder. If the remainder is 0, we're not going to put plus 0 over whatever we divided by. Okay, guys. So I said we were going to do 3 problems. And this was the end of that 3rd problem. So I'm out. Thanks.